Hello dear students, today I will start 5th unit, that is numerical solution of ordinary differential equation. Okay, ordinary differential equation, you know well about ordinary differential equations. Actually in engineering problems there are many situations that where we get differential equations. Many problems can be formalized as a differential equation and with some conditions satisfying the relation, the differential equation. If there is single condition, suppose we have a differential equation just like this: f y x y dash equals to 0. That means x, y and y dash means first order differential equation, and having single condition, that means y equals to something, suppose y 0, for x equals to x 0. Suppose this is given condition, single condition, that means for x equals to x 0, the value of y, because here y is dependent variable on x, so for x equals to x 0, the value of y is y 0. So this is single condition. We come to the engineering problem just like a relation with derivatives and independent variables. That is first order derivatives only. If we restrict, then there is first order differential equation with single condition means initial condition. If there are two conditions, suppose y equals to y1 and for also x equals to x1, for two values of x0 and x, that is x0 and x1, we get the value of y as y0, y1, different value. So then we say that this type of equation as boundary value problem, because initial condition to boundary condition. If we have only single condition, then we can say initial condition, and if only involving first order derivative, then this is first order differential equation with initial condition. If it will contain also y double dash, second derivative, third derivative, then differential equation of higher order and with condition. So if single condition, then initial value problem. If double condition, then boundary value problem. Okay, so this type of differential equation we can solve by our analytical method, that is first of all finding y equals to CF, first 5 CA plus PI, the solution, and CF contain constant. If first order, then 1 constant, if second order, then 2 constant, third order, then 3 constant, and we will solve solution with this condition, then we can get the value of constant and put the value in here, then we can get particular solution, and finally then we can get the value of y for any value of x. These are analytical method, but generally the differential equation arises in engineering problems and in many different fields are not always in the standard form, so that we can solve the differential equation by an analytical method. So for solving that type of differential equations, just we require numerical solution. Numerical solution means by using initial values, from starting initial values, we can find the value of y successively, step by step. Approximation, first approximation, second. Firstly, we use initial from initial condition, and approximation can be get first approximation, second approximation, third approximations, and the value will be more accurate when consecutive two approximation gives nearly same value. Okay, so here for numerical solution of differential equation, ordinary differential equation, here we take only first order differential equation, okay, with initial condition. Clear? So first of all, there are 6-7 methods. First method is Picard methods, Picard's method. Second, Taylor series method, Taylor series method. Okay, then third, Euler method, Euler's method, and fourth, modified Euler method, modified Euler method, and then Runge-Kutta methods, then Milnes method, predictor corrector method, and then Adams-Bosworth method. Adams-Bosworth. Okay. So this type of methods are there. 1, 2, 3, 4, 5, 6, 7, and then 8. These methods we will study in this unit. Okay. So first of all, Picard methods and Taylor series methods. There, in this method, we will get the value of y as a series, which terms will be the function of x. Just like Taylor series, we will get in this method the value of y as a series. And for a particular value, after finding the series, for a particular value of x, we can get the value of y. But here also we will get approximation, first approximation, second approximation, third approximation, and just at each approximation we will get the value of y for a particular value of x. Okay, and if two consecutive approximation give nearly same value, then we can say that is the final value. Okay, so these two methods are basically useful for first starting value, because in this method we require starting value from where we start. So these two value are basically useful for getting a starting value. Okay, and these two method are very simple method. Okay, and then we will come to Euler's method, use tangents to the curve, and then also this method, this method, this method, and this method. Okay, one by one we have to study about these methods. Okay, now first is Picard's method. Okay, so Picard's method is used for solving ordinary linear differential equation of first order with single condition, that is initial value problem for first order differential equation. Okay, suppose first order differential equation means there is derivative, only first order derivative. So Picard's method. In this method, suppose our equation is dy upon dx equals to function of xy. This is our first order differential equation, and with condition, initial condition y equals to y0 at x equals to x0, means the value of x is x0, and for x0 the value of y is y0. This is single condition. This is initial value problem, first order differential equation. For solving this by using Picard's method, here numerical methods is used. So we can also solve this. If fxy is in a standard form, then we can use an analytical method, and using this condition we can get the value of constant, and we can get the value of y as a function of x without constant by using this. Okay, for numerical methods, what we have to do? Just find the value of y. Yes, first approximation, second approximation, third approximation, and with using this condition. And from first approximation, from second approximation, from third approximation, we will find the value of y for a particular value of x. If two approximation gives same value, nearly same value, then that value will be our answer for that value of x, for a particular value of x. So here, for solving this, just we can solve it. How? Just integrate. Also, this is a successive integration method. We can say the Picard's method is a successive integration method. Just like this. Suppose here, integrate this with respect to x0 to x, dy upon dx is equals to integrate x0 to x fx y dx on both sides. Clear? Now we can get from here what? After integration, y at x0 to x equals to here x0 to x fx y dx. From here we see that y at x means y. Here just for writing, y means this is function of x. It can be written just like this also. Okay, y at 0, that's it can be written like this. Y at 1, it can be written like y1. 0 means what? Y at x equals to 0. So y at x 0, it can be denoted as y0. Okay, and y at x is also denoted by y. So here y minus yx means y minus yx0 means y0 equals to this x0 to x fxy dx. So here, from here we can see that we will get just like this, the value of y is equals to y0 plus x0 to x fxy dx. This is our formula. By using this, how can we get the approximation one by one? Just see, in this relation we see that there is an unknown quantity under the integral sign. Integral equation, we can say this is integral equation because we have to find the value of y in terms of x, but in this integral y is under this integral sign, that is as integrand function of x and y. Y is unknown, here is also present, y is unknown. Okay, so this equation is integral equation, and this equation can be used for finding approximation for the value of y. Okay, so start from here. Okay, so first approximation, how can we get the first approximation? First approximation, that is y1. First approximation, the value of y is equals to, for first approximation we use this initial condition. Here just in place of y put y0. Clear? So here y0 plus x0 to x function of x y0. Now this is known value because this is not unknown, this is a particular value. Here just for first approximation put y equals to y0 in integrand now we can solve it. This is a particular value, maybe 0, 1, 2, 3, 4. This is also particular value. Also function is given function, maybe sin x, cos x, x y, x plus y, x square plus y, x minus y, etc. So this we can get this value as a function of x, and we can integrate this as a function of x and apply this limit. We will get, because this is x, so we will get a function of x, and y0 is a particular value. So first approximation is a function of what? X. The first approximation is a function of x, and for a particular value of x, we can first approximate. We can get the value of first approximation just like y. First approximation equals to fn. Fn means this function of x. So just for a particular value of x, a, suppose a, then you can put the value of a in place of x. So you can get fn. F is a particular value, that is first approximation. Now, this is first approximation, and similarly, just use this formula successively. That is, successively integration is required here. Second approximation. Second approximation, put second approximation means second value. The value of y, use this formula, equals to y0 plus, that is our formula. So here x to x0, x0 to x, and function of here first main formula, in place of y just we have to put y1. This was the first value, and we get first approximation, and now use this first approximation here, y1. That is, we have already got this first approximation fa, particular value. So you can put here particular value. Again use the definition of this function. just do this integration and we can get second approximation. This is also the value of function, just like function of x, another function. So we can get for a particular value of x, for a particular value of x, we can also get what? Y second approximation at f1a, this particular value. There is the second approximation. Similarly, we can do another approximation. How many approximations? Suppose nth approximation. Nth. Put y equals to y1 in integrand. Okay. So here how can we write? Put for first approximation y0 1 0, second approximation 1 2 1 1 less. So here put y equals to y n minus 1 approximation, n minus 1 in integrand. Integrand. In integrand. Then what will be the formula? Yn minus yn. Another approximation is equals to y0 plus x0 to x function of x y 1 less than this, because 2 here 1, 1 here 0. So n here n minus 1 approximation and dx. From another approximation can be found by using this formula. But just get approximation for second, third, fourth, fifth, and on by one, same formula. Just replace this y by, in that formula replace y by second and do the integration, and you can get the successively approximations. When two approximations give nearly same value, then that will be the required answer for required value for y for a particular value of x a. Okay, so this is the method of Picard's method, called Picard's method. Okay, now take questions for this. Okay, so here use Picard's method. This is the questions here. Use Picard's method to approximate y when here we see that the value of y approximation we get as a series in x. Okay, means the value of y is a series in terms of x. Okay, because function of x as a series, and just putting the value of x for a particular value of x, we can get the value of y. Okay, so here take an example for the Picard's method. You can get approximation just like Picard method. When x approximate the value y of y when x equal to 0.1, 0.2, given that y equal to 1 when x equals to 0, divided by dx equal to x plus 1, and check the result with the exact value. Exact value means, compare the result with the exact value means, just first of all find the value from by numerical methods, by Picard's method, and then analytically you have to solve the differential equation and put particular value of x, and then you can get also value of y and compare that two value. by analytical method and by numerical methods. Okay, so here solution of this question. Given differential equation is what? dy by dx plus equal to x plus y. dy by dx equals to x plus y. Given that y equals to 1 when x equals to 0. When x equals to 0. That is, this is y0, this is x0. This is y0, this is x0. Okay? So this is given differential equation. Just we have to approximate, we have to find the value of y numerically. For we have to find the value of y numerically for x equals to 0.1 and x equals to 0.2. Clear? So first of all, for numerically finding the value of y, just use here Picard's method. So here we can write dy upon dx is equals to x plus y, that is function fxy, that is function fxy, means fxy equals to x plus y. Okay? Using Picard's method, we get what? First order derivative, y equals to y0 plus integration of x0 to x function of x y dx. This is our formula by Picard's method. Okay? So, implies y equals to y0. Here, this is y0 and this is x0. Clear? So, in place of y0, we have to write 1 plus x0, 0. X fxy means x plus y. X plus y dx. Clear? Now, for first approximation, this is our formula. Okay, we use this initial condition like this. Now, this is our formula due to Picard's. Okay, so now first approximation. First approximation, put what? Y equals to y0 equals to 1 in integrand. So we get first approximation, value of y, first approximation equals to 1 plus integration of 0 to x, x plus 1 dx. Now we can solve it. Okay, so y1 equals to 1 plus, so just doing it, what will be the value of x square by 2 plus x square by 2 plus x square by 2 plus x, just integrate and apply limit, x in both, so 0, so second limit finish, x, so x square, x plus x square by 2. This is first approximation. Clear? This is first approximation. From this first approximation, now first approximation for the value of y at x equal to what this and at x equal to this we can get. Okay. So how we can get it? Just one by one you have to do same type of process. Here. Implies first approximation, this is equals to 1 plus, now x equals to 0.1, 0.1. So here 0.1 plus 0.1 square by 2. Because we have to find the value of y at x equal to this, x equal to this. Okay, so just doing the process. What? Put here, this is first approximation. So put x equals to 0.1 for, okay, this, and this can be solved. Just do it by calculator. You can get 1.105. 1.105. Okay, first approximation. And similarly, y first approximation is equals to 1 plus 0.2. For also 0.2 we can get just like this, 0.2 plus 0.2 square upon 2 for x equals to 0.2. So this can be solved. Y equals to what? 1.22. 1.22. Just do it by using calculator. You can do. Okay, this is the first approximation. For x equal to this, the value of y is this. The for x equal to 0.2, value of y is this. Clear? Now, second approximation. Our main formula is what? This. Clear? This is. Now, second approximation. Second approximation. Put y equals to y1. y1. That is this. Not particular value. This value. Y equals to y1. That is this value. This value. Just previous value. 1 plus x square by 2 in integrand. That is y2 is equals to what? From the main formula, what we will get? 1 plus equation 1, 0 to x plus in place of y, just we have to write y1. That is 1 plus x square by 2 dx. Now we can integrate it. So 1 plus just 2x 1. So what we will get? 1 means x, 2x means 2x square upon 2 plus x cube means x cube upon 3 into 2 6. Just this is integration 0 to x. So we can get just like this 1 plus first approximation, this second approximation we can get like here 1 plus x square plus x cube by 6. This y second approximation. This is second approximation as also a function of x as a series, finite series, this as a finite series. And similarly you can get third approximation, fourth approximation, fifth approximation by successive integration, and at all the stages you can get the value of y for x equal to 0.1, x equal to 0.2. Okay, so here just putting the value, this was the first approximation. Now implies y2 for, just put value here for x equals to 0.1. You can get the value just like this. Just you have to calculate. Okay, here for x equal to 0.1, and just calculating the value, you can get the value 1.11017. Second approximation 1.11017. Just you have to calculate it. Okay. And similarly, second approximation for this value 0.2 for x equals to 0.2. So just use this, then 1.24133. 1.24133. Just calculate 0.2, put here, and calculate it, you can get this value. So this is second approximation. This is second approximation, and this was the first approximation. This was the first approximation. Okay, this was the first approximation. Similarly, you can get third, fourth, fifth approximation. When two approximation give nearly same value, that will be our answer. So here 1.11017, here 1.105. So just desire stage of accuracy, that is 4 digit, 5 digit, 6 digit, just this second approximation. Similarly, third approximation give the value. For third approximation, what we will do? For third approximation, just this is repetitive process. Numerical method means repetitive process. You can do it computer programming, that's so why. Okay, so here if we, for this method, Taylor method, Picard's method and Taylor methods, there are requiring integration process and also differentiation process for Taylor series. That's why these are not used every time, because these are the useful method for getting starting value for the other methods. Okay, so here just for third approximation, what we have to do? Here we will put second approximation value, that is this value, 1 plus x square plus x cube by 6. This value in the or required formula, then that will be 3. Third approximation, here just 1 plus x cube by 6 dx, and just do it this integration, and you can get the value y cube equals to 1 plus, just doing this integration, what 1 means x, 2x means 2x square by 2, so x square plus x cube by 3 plus x for 4 by 4, 24, and so on. So this is third approximation. This is third approximation. In a similar process, you can now from here we can get third approximate value for what? Just put for x equals to 0.1. What x equal to 0.1? Third approximation gives 11034. 1.11034, and y third approximation for x equals to 0.2 for second value, because our record value is this now. So just putting this 1.24273, 1.24273, just you have to do it, calculate it. You can use calculator. Now, fourth approximation can also be found. Fourth approximation. For fourth approximation, here we will put y equal to y3, that is this value. This value. Here. This value. In integrate. And then we can get fourth approximation. Okay. As a series. And we can get also fourth approximation. So this is a one set, this is one set. Okay. Or value. First approximation is this. First approximation. This is second approximation. This is third approximation. This is fourth approximation. In a similar process, you can get the value of y4, fourth approximation, just like 1.11034. 1.11034 for x equals to 0.1 and y4 equals to just 1.24280. 1.24280 at for x equals to 0.2. This is fourth approximation, and also you can get fifth approximation. But here we see that these two are nearly same value up to, because 242, 242, 110, 110, 3434, 273, just small difference. So we can take this as the value of y for x equal to 0.1, and this is the value of y for x equal to 0.2. Okay. Here, this is first approximation, second approximation, third approximation, fourth approximation. You can get also fifth, sixth, seventh, and eighth. Whenever two successive approximation give nearly same result, then you can conclude that this approximation are the values, required values for numerical values for x equal to 0.1, for x equal to 0.2. Okay, so this is our result. Now, we will check this value by using analytical method. Okay, by using analytical method. So analytical method is what? Just you have to solve this differential equation. Just you have to solve this differential equation analytically. That is finds the differential equation, solution of differential equation. So this is first order differential equation. We can solve this. Okay. By any of the methods, separable form, linear equation, homogeneous equation. So here we see that just we have to find the solution of this differential equation, as we have already studied in the first semester, just like this: dy by dx minus y equals to x. Linear equation. Linear differential equation of first order. First order. So it can be solved by finding its integration factor. So here, just like this format, dy by dx plus py equals to q. If is what? E to the power integration p dx. Solution is what? E if y into if equals to integration of q into if dx plus c. This solution. So this is the method. So by this method, just solve this. Also here condition is equal y equals to 1, x equals to 0. So solve it. Solution is here. P equals to what? Minus 1. Q equals to x. Therefore, if equals to what? E to the power integration of p dx e to the power integration of minus 1 dx e to the power minus x. If is e to the power minus x. Therefore, its solution is what? Y into if means what? E to the power minus x equals to integration of q means what? X into e to the power minus x dx plus c. This is an analytical solution with arbitrary constant here. Now y e to the power minus x equals to, here just first function, second function we can do by parts method. So here first function x, second function e to the power minus x minus, this is first value, minus integration of this minus integration differentiation of first function 1 minus e to the power minus x integration dx plus c. So we can solve minus x e to the power minus x minus plus and also e to the power minus x integrated minus e to the power minus x. So this is minus e to the power minus x plus c y e to the power minus x. Now minus is in everywhere, so we can write like this: y equals to minus x minus 1 plus c e to the power plus x. So this is analytical solution with constant. Now for finding the value of constant, just use this condition. Okay, so here implies using this y equals to 1 equals to minus of x equals to 0 minus 1 plus c e to the power minus 0. Y equals to 1, x equals to 0. Okay, so solve it. 1 equals to 0 minus 1 plus c, so implies c equals to 2. Therefore solution is what? Y equals to minus x plus 1 minus x plus 1, c equals to 2 plus 2 e to the power minus x. This is our solution in terms of x. Here not constant is there. Now put x equals to 0.1. Just put x equal to 0.1 in above. Okay, so and we will get y at 0.1. Y at 0.1. So minus 0.1 plus 1 plus 2 e to the power minus 0.1. Okay, so you can calculate it. Minus 1. So here not minus sign is there, here plus sign. Okay, plus sign. So this plus sign. Clear? This. And just you can calculate it by using calculator. This into this and this. Just you can see that this is equals to 1.11034. 1.11034. Just calculate it. You can see just like this value. Clear? So analytical method also give the value just like same value. Okay, and also y.2 is this minus of 0.2 plus 1 plus 2 e to the power 0.2. Clear? This 2428. 1.2428. It gives just like this value. Just use calculator and you can get the value. Okay, so these two value nearly about same value like this. So above two methods, that is numerical methods and analytical methods, gives same approximation up to 4 decimal places: 2428, 1103, 1103, 2428. So this is our solution due to Picard's methods, numerical solution. So very simple. For every questions you have to do this type of process. Here fxy is this. Its format should be very clear. That's why we can do integration. And at each approximation we require doing integration. After integration we get as a value of y as a series, and for at each stage we have to find the required value for the y. And if two consecutive approximation gives nearly same value, that will be our numerical solution. Okay, so this is the method of Picard's due to. Okay. Now, second method is Taylor series method. Okay, Taylor series method. Second method. Taylor series method. Okay, so Taylor series method also give the value of y as a series. By using Taylor series we can find the value. Taylor series, we know about Taylor series from previous classes. Just here also we have to find the numerical solution of just first order differential equation dy by dx equals to xy, and for y equals to y0 at x equals to x. This is initial value problem. Okay, first order derivative is also involved in this differential equation, first order differential equation. We will find a numerical solution by using Taylor series method. Here, just in the previous method, Picard's method, we have seen that the value of y is a function of x as a series form. Here also at the stage, different stage of, just in this method, just we find the value of y as a Taylor series. We know Taylor series, the formula, just remember, if y is a function of x, just we can also write like this. Clear? And for a value of x at x0, okay, for next value, if equally distributed value, then next value will be x0 plus h. H is small difference between first value to second value, and here h equals to, we can write x minus x0, this difference. By using this difference we write the Taylor series. Just here x plus h is equals to what we have to write, yx. If this is a, then fx plus what, h, f dash x upon 1 factorial plus h square by 2 factorial f double dash x plus and so on. We can also write like this, yx plus h by 1 factorial y dash x plus h square upon 2 factorial yx double dash plus and so on. We can also write this as yx plus h equals to what? X minus x0. So x minus x0, x minus x0 and y dash double dash, sorry, dash x plus y 1 factorial x minus x0 square y 2 factorial yx double dash and so on. Okay, this is Taylor series. Okay, now here x 0, we can use x 0 because just corresponding to this value, the value of y is y0. So we can use here yx0, yx0, yx0. That is, we require the value of this, value of this, because x0 is given. This is Taylor series explanation of the function about x0, about x0. So x minus x0 is there, x minus x0 is here, and here y x0, y dash x0, y double dash x0, y triple dash x0, y 4 dash x0, and different order derivatives at initial value. Just first of all we have to find this value and then put that value in this formula. Then we can get the value of y as a function of x. And from this value we can get the value of y for a particular value of x. Okay, so this is Taylor series method. So here our method will be like this, the formula just. Here different order derivatives, the value of different order derivatives of y we require at initial point. Okay, just if we are giving this, then we can get, this means what? Y dash equals to fxy. Now we require y dash, y at 0. Y at 0 means y0. Y at 0 means y at x0. Y at x0 means this is y0. The value, this value is given. So y at 0 is given. Y dash at 0, how can you find this value? Just x0, y0 use here. The value of y0 use here and x0 is here. Then you can get the value. But y dash equal to this. Now y double dash, just differentiate it. Differentiate it, f dash of xy. After differentiation, just put the value at x equal to x0 and y in place of y, y0. You can get second derivative. Similarly, you can get third derivative at 0, f double dash xy. In place of x and y, put x0 and y0. Just you can get all the different order derivatives. So by using this derivative, the value of y will be what? We know the value of y will be by using Taylor series. By using Taylor's series expansion of y equals to yx about x equal to x0. Is given by y equals to y0 plus x minus x0 upon 1 factorial y dash 0 x minus x0 square y 2 factorial y double dash 0 and so on. This is Taylor series expansion. Okay, and we can get series like this. Third term will be what? X minus x0 q upon 3 factorial y triple dash at 0. These derivatives at 0 can be found by differentiating this successively and putting the value of x0, y0 at in place of x and y. After getting that derivatives, just put here. Then we can get, this is our formula. And from this formula, y0, value of y0, y dash 0, y double dash 0, y triple dash 0, just putting, you can get the value of y as a function of x. So we can get the value of y for any value of x. That will be our approximation. First time use this first approximation. Second time use here first approximated value. Just total Taylor series you have to use for this. In place of this, first time we use y dash equal to this. Second time, in place of y, just use the value by getting this value. And you can get another formula. That is the second approximation. Okay. So take a question for Taylor series. Then we can get better idea how can we solve numerically differential equation by using Taylor series method. Okay, so here Taylor series method, for Taylor series method just use here use Taylor series method to obtain an approximate value of y at x equal to 0.1 and x equal to 0.2 for the differential equation dy by dx equal to 2y plus 3 to the power x y0 equals to 0. Compare numerical solution with the exact solution. Just same type of questions. Here, solution given equation is dy upon dx equals to what? 2y plus 3 to the power x. 2y plus 3 e to the power x. And here condition is y0 equals to 0 here. y0 equals to 0. y0 equals to 0. That is y equals to 0 for x equals to 0. That is y0 equals to 0 for x0 equals to 0. Not x0, just like this value is x0, y0, this value is x0. This is value. Clear? y0, y equal to y0 means value of y0 is 0 and value of x0 is 0. Okay? So, this is our given equation. We have to find value of we have to find y for x equals to 0.1 and x equals to 0.2, just like said in the previous question. Okay, here this, and compare the numerical solution with the exact solution also. Okay, so here just first of all we have to find the different derivatives of this function. Okay, so first of all we are giving what? This implies what? Y dash. This is dy by dx means y dash. So y dash equals to what is given? 2y plus 3 e to the power x. So y dash at x0, that is y dash 0, is equals to x0 y0. Just you have to put the value x equal to 0 y equal to 0 here. So 2 into 0 plus 3 into e to the power 0 equals to 3. So this is the value of 3. First y dash 0 is equals to 3 we get. Okay. Now for getting second derivative, so differentiate it. Differentiate 1. We get what? Y double dash. Just differentiate. First time, one time more, second time. So here, differentiate this. 2y means y dash. This 3 e to the power x means x with respect to x. So this is second derivative. Here, for finding y double dash at 0, just put y dash to y dash at 0 plus 3 e to the power x0. x0, that is 0, 0. So this is equals to what? 2 y dash 0 is equals to 3. So 2 into 3 plus 3 into 1 equals to what? 6 plus 3 equals to 9. So y double dash 0 equals to 9. Y double dash 0 equals to 9. Similarly, you can get other values. So implies y double dash 0 equals to 9. So one by one we are getting the values. Y dash 0 equals to 3, y double dash 0 equals to 9, y triple dash 0 equals to something, y 4 dash 0 equals to something, y 5 dash 0 equals to something. Just find this value. Clear? One by one, just you have to find the value. Clear? So what? Y triple dash 0, you can just again differentiate it. 2y double dash plus 3 to the power x. So y double dash at 0 means 9. Here 9 into 2, 18. 18 plus 3, 21. So we can get value 21. Similarly, just 45, 93, 45, 93. These are the values. Okay, you can get figure. Now by using Taylor series. Taylor series. This is the process for finding derivatives, because these derivatives, successive derivatives are required for, this is for initial value problem. Initial value is this. At initial value we have to get all the derivatives. Now write Taylor series expansion. Now using Taylor series expansion about x equals to x0 is given by what? Y equals to first value y0, x minus x0 upon factorial 1, y dash 0, x minus x0 square upon this y double dash 0, and so on. Okay, so we can also write third up to third, because it will be very clear then. Third practice. Okay, yes. Just put the value here. Y equals to y0 is equals to what? 0. Okay, 0. Plus x minus x0 is also 0. Y dash 0 equals to 3. Plus x minus 0 square by 2 factorial means 2 and y double dash 0 is equals to 9. Plus x minus 0 power 3 upon 3 factorial y triple dash 0 21 and so on. Okay, so up to higher terms you can write all the terms just in a similar fashion. So here we get this 3x plus x square 9 by 2 x square 9 by 2 x square plus what? X cube 3 into 2 into 1 7 by 2 here 7 by 2 x cube 7 by 2 x cube. Similarly just write x to the power 4 15 by 8 x to the power 4 15 by 8 x to the power 4 also 31 by 40 x power 5 and so on. Clear? So this is the Taylor series or required series is this. Okay? Now for x equals to 0.1 we can get the value. For x equal to 0.2 we can get the value. Okay? This is first approximation. And for the second approximation, now just you can write here. Now to find the approximate value of y for x equals to 0.1, for x equals to 0.1, put x equals to 0.1 in above. Expression. We get just here put x equals to 0.1. So y at 0.1 is equals to 3 into 0.1 plus 9 by 2 into 0.1 square plus 7 by 2 into 0.1 cube plus 15 by 8 into 0.1 power 4 plus 31 by 40 into 0.1 power 5 and so on. Okay, just like this, and you can calculate the values at each stage. So first stage given 0.3, 0.045. Just use calculator for calculating it. Okay, so here 0.3, 0.045, 0.045, 0.0035, 0.0035 and 0.0001875, 0.0001875 plus 0.123450775 1234575 plus, just we see that the negligible term because 0.0000, so negligible terms. Now add this term, we can get value 0.34869, 0.34869 525. 525. This is the approximation of the value of y for x equals to 0.1 of this initial value problem. Okay, so 0.1. Similarly, for 0.2, you can get. This is the use of Taylor series method. From here, just we have to find different order derivatives of y at x0 initial value and put in Taylor series formula. Then you can get this Taylor series. Okay. And from this series, we can get the value of y for any particular value of x. Okay. So this is for x equals to 0.01. Now for x equals to 0.02, also for x equals to 0.2, for 0.2 we get, just put here y equals to 3 into 0.2 plus, just put the value here, 9 by 2, 0.2 square, 7 by 2, 0.2 cube, 15 by 18, 8, 0.2 power 4, 31 by 40, 31 by 40, 0.2 power 5, and so on. Okay, so here also you can get value by using calculator. Just this is first approximation, and second approximation we will get here 0.6 plus 0.18, 0.028, 0.18, 0.028. Just use calculator and write the value here. 0.003, 0.00025, 0.003, 0.00025, and plus negligible term, negligible quantities. Okay. Now add this term, y at 0.2, y at 0.2. Adding this, you can get the value 81125. 81125, y 0.2. This is the approximate value for this is for x equals to 0.1 and just we get this 0.81125 for x equals to 0.2. This is the approximation. This is our answer. Okay, numerically approximate value. Numerically approximation of y by Taylor series method. Okay. Now also in these questions, just check by compare the numerical solution with the exact solution. Exact solution means analytical solution. So now we have to find the analytical solution of this. Okay. So from here we can also find the analytical solution. This is numerical solution. This is numerical. Now analytically we can get solution of given equation as dy by dx minus 2y equals to 3 e to the power x implies dy by dx plus p y equals to q, where this is linear equation. So here p equals to what? Minus 2. Q equals to what? 3 e to the power x. Therefore integration factor is equals to e to the power integration p dx equals to e to the power integration minus 2x minus 2 dx e to the power minus 2x. Okay. So its solution is given by what? Y into if equals to integration of q into if dx plus c. So this implies y into if means e to the power minus 2x equals to integration of q means 3 e to the power x into e to the power minus 2x dx plus c. So here we can find solution y e to the power minus 2x equals to 3 common e to the power x e to the power minus 2x e to the power minus x. So integrate it minus e to the power minus x because e to the power x e to the power minus 2x e to the power minus x minus e to the power minus x integration. So this plus c. So we see that the value of y from here, the value of y equals to, we can write minus 3 e to the minus 2x, just multiply both sides by e to the power plus 2x. So this is vanished, e to the power plus 2x e to the power x plus c e to the power 2x. Okay, so minus 3 e to the power x plus c e to the power 2x. Just exact solution can be found by finding constant c by using x0, 0, 0, x equal to 0, y equal to 0. So here put x equal to 0, y equal to 0. Implies 0 equals to minus 3 e to the power 0 plus c e to the power 2 into 0 for y equals to 0 at x equals to 0. Okay. So from here we get like this minus 3, 1 plus c. So c equals to 3. C equals to 3. Okay, c equals to 3. 3 e to the minus 3 e to the power 2x minus 3 e to the power x is the exact solution. So the exact solution is what? Y equals to this line. Put C 3. 3 e to the power 2x minus 3 e to the power x. 3 e to the power 2x minus 3 e to the power x. This is exact solution. Implies y point 1. Just you can find the value of y point 1. Just put point 1 here. 3 e to the power 2 into point 1 minus 3 e to the power point 1 equals to, and y point 2 equals to 3 e to the power 2 into point 2 minus 3 e to the power point 2 equals to. Just calculate it by using calculator. E to the power this, e to the power this, and e to the power this, and just calculate it. You can get the value as 0.34869. 0.34869, and another value 0.81126. 0.81126. Okay, so this is the value by direct or exact solution or by analytical method, because the given differential equation is a particular type linear differential equation. We can get the solution for initial values, and after finding the value we can get value of y at point 1, point 2 just. So this exact value and numerical value just like same value. 81126, 81126. 4 up to 4 decimal places gives same value. Okay. So, which is exact value? These are the exact value. We see that exact values and numerical values are same up to 4 decimal places. Okay. So this is solution approximation of y by using Taylor series method numerically, and is from exact. Okay. Now two methods are completed. Picard's methods. Just do practice some of the questions from your book. Okay. Now I will give two questions, and you have to solve these two questions and send me PDF file for your attendance. Okay. So Picard's method is very clear. For Picard's methods, we have to integrate successively. Successive integration is involved in Picard's methods, and successive differentiation is involved in which method? Taylor series method. Okay. So first of all, for finding in Picard's method we can get approximation, but Taylor series gives the approximate value. In the Picard's method, just what we are doing in Picard's method, suppose dy by dx equals to fxy, and this is y equals to y0 at x equals to x0. This is our problem, or initial value problem. Okay. For solving Picard's method, what we have to do? From here, by integrating, we get y equals to y0 plus integration x0 to x f of this value here, xy dx. This is our formula for Picard's method. Okay, formula. Here, y0, this is given value, x0 is here, fxy is this. If fxy equals to function of xy, just put here, but in place of y, you have to put y0 first and then integrate it. The format of this function should be such a way that we can integrate easily, then we can do it very fast. Otherwise, if integration is not possible, then at the first stage you can get first approximation, that will be our answer. Okay, so step by step. But first time just use y0 is here, then integrate it. First approximation. Second approximation, use this formula. In place of y, just put the value of this value. Then you can get second approximation. Similarly, we can get third approximation. For third approximation, use this formula. In place of y, just put what? y2, the value of x. Value related involving x. And you can get third approximation. Similarly, you can get. And at each approximation, find the value for particular value of x. At each approximation. If two successive approximations give near about same value, then you can consider that is the solution, numerical solution for that particular value of x, that is numerical value of y, that is particular value of x for this initial value problem. Okay, so this is the process of Picard's method. Okay, so solve by using this method these questions. And similarly, in this method, Picard's method, successive integration is involved. Similar to this, successive differentiation is involved in Taylor series method. In Taylor series method. What Taylor series we know? Equation is this, dy by dx equals to fxy. This is equation, y equals to y0, x equals to x0. This is our initial value problem involving first order derivative. Okay, so here Taylor series we know, y equals to y0, x minus x0, or 1 upon 1 factorial, y dash 0 plus x minus x0 power 2 upon 2 factorial, y double dash 0, and so on. Just we have to find the value of y as a series form. For finding series form, this expansion of Taylor series about the point x equal to x0. So just find y0, we have y0. Just this value is given initially. And for x equal to x0, just we have to find the value of y dash 0, y double dash. That means what? Derivative. This is also given, y dash equals to fxy. Just put here x0, y0, then you can get y dash 0 this. And find, again differentiate, again differentiate, again differentiate. We get in terms of value x and y. Just put here initial value. Then you can get all the values at 0, 0, 0, 0, at 0, 0, 0, 0. Put all these values in this series. Then you can get the value of y here as a series terms. And finally, for any value of x, we can find y from our series. That is the Taylor series. By using Taylor series, we can approximate the value of y. Okay. So do these two questions and send me PDF file for your attendance. Okay.